Now let's talk about our impedance and admittance Smith chart in a little bit more detail. So since I just mentioned that if you have any impedance on the Smith chart and you take its antipodal point, you end up with the admittance of that. You can essentially imagine doing that for every single point of the Smith chart, which might sound tedious, but if you actually end up doing this for every single point of the Smith chart, you will basically end up reversing the Smith chart exactly as this picture shows. So in theory, we can basically take the Smith chart, take the antipodal point of any Smith chart, and go for a main impedance Smith chart to an admittance Smith chart. So you can literally take the Smith chart that I basically gave you, which I don't have it here, just rotate it like that, exactly as I have it on the figure, and basically have now an admittance Smith chart. And where that becomes useful is that you can now overlay the two Smith charts on top of each other and end up what we mostly call impedance and admittance Smith chart, or sometimes people will call it the YZ or the ZY Smith chart. Now you can actually use this more powerful tool and basically put any point on the Smith chart and read both its real and imaginary part on the impedance domain and real and imaginary part in the admittance domain without actually doing the lambda by 4 transformation, without taking the antipodal point, because you have already done it for the Smith chart to turn it into an admittance chart. So let me actually give you an example. Here is exactly the same Smith chart and admittance chart with just fewer lines, so we can focus a little bit more on some numbers. So let me actually pick an easy point. So let's pick this point right here. Now, with the red line that you see here, you're basically looking at the impedance values, while with the green lines, you're looking at the admittance values. So let's focus our eyes right now on the red lines and try to read for this point what is the value z. So it's going to pass through this red circle on the real part. So this is equal to 1 real part. And it's going to pass through this circle, which is the imaginary part of also 1, where on the upper side of the Smith chart, so this has a value of 1 plus j1 ohms in terms of impedance. So real part, resistance is 1, reactance is 1 as well. Now let's focus our eyes on the green lines. If I look at the green lines, then this is the green line where the real part of the admittance will be on, and I'm making it purposely thick so you can see it. So the value there, as you can see, is actually 0.5. So the y now of this load will have a real part of 0.5. And if you look at the imaginary part on the admittance chart with the green line, it actually passes from this line here, which has a value of negative 0.5. Now remember that I have already reversed my Smith chart by 180 degrees, which means on the admittance now, on the upper side, I'm negative. So this guy will be negative j0.5. And I shouldn't actually have put the values here because this is really normalized, so I should not have put ohms, but I wanted to emphasize that this is actually the impedance with the red, and this is the admittance with the green. So it's really a matter of your preference whether you would like to use the simple Smith chart that we discussed last time and do this lambda by 4 transformation, this 180-degree rotation to grow from impedance to admittance. Personally, that's my choice. But it's also equally good to use the complicated or more complete Smith chart, the YZ Smith chart, where you don't move on the Smith chart, but you're reading things on 2 scales, exactly as I basically read here. Of course, this transformation that I showed you here is very easy to verify with a little computer, but it's also nice to see that it works really well on the Smith chart.